Okay, so when you're talking about transformation geometry, you've got 4 main transformations that an object can go through. So on this page here, page 103 in your book, there are the 4 examples here. Alright, so I'm going to label these here now. The first one is axial symmetry. And that is symmetry through an axis. That's the axis there, the axis of symmetry. It's basically a mirror image of the object. So whatever it travels to the axis on this side, it travels out the same distance on the far side, and you get a mirrored image. You see here, the main fundamental principle here is that the projection lines or the projected lines are always perpendicular to the axis. The second one then is translation. So a translation, just write it down, is just moving an object from one point to another. Okay, so point A here moved roughly 30 degrees, I'd say that is, and it moved about 60 millimeters. Alright, the third one there is similar to axial symmetry, but it's central symmetry. And that is symmetry through a point instead of an axis. You see the point of symmetry here instead of the axis of symmetry. And what you get then is an inverted mirrored image of the object down here. Alright? And the last one then on this sheet is a rotation. These are arguably the most difficult, and you're rotating about a point either on the object or off the object, and you're rotating through a certain angle, and you're rotating clockwise or anti-clockwise. Alright, in this case it's rotating clockwise. Point A is rotating about probably 75-80 degrees there clockwise. Alright. Okay, so the first one we're going to move on to then is our axial symmetry. It is on page 105 in your book, and I'm going to do some of these more difficult examples of axial symmetry. Alright, so in axial symmetry, as I said, we're going to do two examples. We need to go perpendicular to the axis with all of our points. So the axis here is at 60 degrees, top right example here. That means that all my points are going to go at 30 degrees through that axis of symmetry. So I'm drawing light lines. I'm drawing from A, I'm drawing from B. Hold on 1 second. So I'm drawing from A and B through the axis of symmetry and out the far side. These are construction lines, they're light. I'm going to leave the center points there that aren't labelled for a second. I'm drawing from C. I'm also drawing from D. Alright, now I'm going to mark the outside of this object before I move on. The easiest way to transfer these points out to the far side of the axis is you put the point of your compass on the axis of symmetry, like I am now. Open it out to A in this case. We're going to start with A. Swing it over to the far side, to the projected image that you're going to create. Same thing for B. That'll give us a B1. Same thing for C. We'll be given a C1. Same thing for D. We'll be given a D1. Alright, so those are going to be my new points out here, and I'm going to label those as I said them there. So A1, B1, C1 and D1. Now I could draw in those points if I wanted, so I could join them all up, and I'm going to do that right now. So A1 joins to D1, D1 joins to C1, and A1 then joins down to B1. Now how do I get the rest of my points? Well, the first thing I need to do here is I need to label them. So I'm finished at D, A, B, C, D, E. Start up here, F, G and H. And I'm going to bring those points up to the very same. So I'm going to start with E. I'm going to bring up F. I'm going to bring up G. And I'm going to bring up H. All perpendicular to the axis of symmetry. Again, same technique. I'm putting my compass on the axis of symmetry, open it out to the point and getting the image of that point up here then. And again, I'll just move down to this point here, get the image of it. Then I'm going down here below. I'm going to get the image of all these points here. That's going to give me a mirror image of my shape because it's axial symmetry. That's what we're looking for. So, let's start joining those now. They should match up, and they do. And here is the image of my shape under axial symmetry. You can see there it's a mirror image of itself. Now, we come down here then to this example down on the bottom left, which is possibly a slight bit more difficult. Now this example down here shows a logo. You have to apply axial symmetry to the logo. A is going to move to A1. We need to locate the axis of symmetry first. First thing I'm going to do, join A to A1, because we know they're that's the image of A. Alright, then we'll have a look up here. So we know if we take A and A1 here for an example, we know that the axis of symmetry is perpendicular to the projected line between the two, and we know that it's halfway between the two because we open our compass to get it. So what we'll need to do is we'll need to bisect that line to get the perpendicular bisector of it to draw our axis of symmetry. Now we could measure it and we could just draw it with our set square, but this is more accurate and correct way of doing it. So put my compass on A1, open it out to more than half, scribe an arc above and below, leave the compass the same, scribe an arc above and below from A2, from A as well. Now we're joining both those arcs. That there, I'll draw it in heavy, that is my axis of symmetry. Perfect, right? That is perpendicular. That's halfway between A and A1. Now, what do we need to do after that? Well, what we need to do is we need to join all the points, or draw all the points down through that axis of symmetry at the same angle as the original line A to A1. So we're setting up our sliding set squares. You see I'm holding my T-square there at an angle on the board, sliding my set square down along it. I'm going to bring B across, I'm going to bring D across, and I'm going to bring C across. And when I say across, I mean I'm bringing them across the axis of symmetry. Just going to move down and extend D and C, and I'm setting up my sliding set squares. I want this to be accurate, somewhat accurate. I'm not going to waste your time, but somewhat accurate. Now, same principle applies then after that. A, and I'll just show you A to A1. Alright, that's already there for us. I'm just checking my work. B gives us a B1. C, or D, sorry, I'm going to next. D is going to give us a D1. I'm just working down along the line, that's why I'm going to D next. And C then is going to give us a C1. And I can label all those points: B1, D1, C1. And now I can join up those points there and create the outside of that shape. So I'm going to start doing that. A1 to B1, A1 to D1, B1 to C1, and C1 to D1. Now, when I have that done, the same thing as before with the center points. I'm going to do these in red so that they're highlighted. We'll go E, F, and G, right? We know that G is down here with D1, so I can call that G1 already. Sliding set squares. Get the angle. Move E down to the side it's on. It's between A and B, so between A1 and B1, E1. And F is between B1 and C1. Alright, so now to draw that in, I'm going to join those points that I've created. Like that. Alright, there is the image of that original shape under axial symmetry, and we found the axis while we were doing it. Okay, so that's that. We'll be moving on to the next one now. Now with central symmetry, which is the next one here on page 106, I don't feel the need to draw these because these are very similar. With these, all you do is the original point is going to go through the center of symmetry rather than the axis, and it's going to end up mirrored down here on the far side, mirrored and inverted. You see the key principle there. So I've drawn A through point P and out the far side, and what I've done is I put my compass on point P, opened it out to A, and marked A1 on the far side. You can see the distance between A and P and A1 is the same, and it's the same thing then. You get an inverted mirrored image. Here again we have another example, here again another example, and here again. Okay, these are really simple. Moving on to the next page then, we've done those, so we're happy with that. 6, 105. Now, after that then we're going to move on. And in the next video we'll be talking about rotations, alright? And we'll also talk about transformations, and once we've that done we have all of the topics of transformation geometry covered, alright?